Hi there, and today we're going to be looking at sequences of numbers. We want to be able to recognise what a number sequence is. In particular, we'll be dealing with arithmetic sequences. But a sequence is a set of numbers that follow a rule. So in actual fact, 1, 2, 3, 4, 5, 6. That's a sequence of numbers, isn't it? It follows a rule. That set of numbers increases by 1 each time. Similarly, 2, 4, 6, 8, 10. It's a set of numbers that follow a rule. The numbers increase by 2 each time. So that's all we're talking about, a set of numbers that follow a rule. That is a sequence. Now there are some special sequences. It's a special sequence, and you should be able to recognise these. 2, 3, 5, 7, 11, 13, 17, 19, 23. Hopefully, most of you recognise that for what it is. It is a sequence of odd numbers. They're all odd numbers. Odd numbers can't be divided by 2. The next set there, 1, 4, 9, 16, 25, 36. A set of numbers that follow a rule. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, and so on. They're squared numbers. It's a sequence of squared numbers. Next set, 1, 8, 27, 64, 125, 216. 1 cubed. So 1 times 1 times 1 is 1. 2 cubed. 2 times 2 times 2 is 8. 3 cubed. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5, 5 cubed is 125, and so on. That's a sequence of cubed numbers. 2, 4, 8, 16, 32, 64. 2 multiplied by 2 gives 4. 4 multiplied by 2 gives 8. 8 multiplied by 2 gives 16. 16 multiplied by 2 gives 32. 32 multiplied by 2 gives 64. So each time you're multiplying the preceding number by 2 to find your new number. Similarly, 3. 3 times 3 is 9. 3 times 9 is 27. 3 times 27 is 81. 3 times 81 is 243. So you're multiplying the previous number by 3 each time. 10, 100, 1000, 10,000. Multiplying the previous number by 10 each time. Now, at the bottom there, I said what's meant by the nth term. So that's something you need to get in your head. So terms. First term, the second term, the third term, the fourth term, the fifth term. So the first number in the sequence, the second number in the sequence, the third number in the sequence, the fourth number in the sequence, the fifth number in the sequence, and so on. First, second, third, fourth, fifth. Okay? The nth term is any term in the sequence in the future. And we'll talk a bit more about this later. But one of the things you're going to need to be able to do with arithmetic sequences is you're going to be able to say, right, okay, I know what the 50th term is going to be, I know what the 100th term is going to be, without having to write out the whole sequence to get up to that particular term, that particular number. Okay? So first term, first number in the sequence, second term, second number in the sequence, third term, third number in the sequence, and so on. That's what's meant by term. You must understand that. Now, an example of an arithmetic sequence. An arithmetic sequence is a sequence that increases by the same number each time. arithmetic sequence has the same difference between each term and the next. So it increases by the same number each time. So what is this increasing by? We've gone 5 to 7, we've gone 7 to 9, we've gone 9 to 11, we've gone 11 to 13. So the sequence is increasing by 2 each time. So the difference between the numbers is the same, so it is an arithmetic sequence. The first term is 5, the second term is 7, third term 9, fourth term 11, fifth term is 13. Can we calculate the next 2 terms? What's the next 2 terms going to be? Increase 13 by 2 is going to give us 15. Increase 15 by 2 is going to give us 17, and so on. Okay? So an arithmetic sequence increases by the same number each time. The difference between the numbers is the same each time. 8, 11, 14, 17, 20. We're increasing by 3 each time. Increasing by 3 each time. Okay, so our increase is 3 each time. What's our next 2 numbers going to be? It's going to be 23 and then 26. We're increasing by 3 each time, an arithmetic sequence. First term, second term, third term, fourth term, fifth term. What are we increasing by each time here? We're increasing by 3 each time. So our next 2 terms would be 17 and then 20. We're increasing by the same number each time. We're increasing by 3 each time. An arithmetic sequence. Now, what about this one? What's the difference between each of these terms? First term, second term, third term, fourth term, fifth term. What's the difference between each term? Well, this time we're actually going down by 2 each time. So our difference is -2. We're taking 2 away each time. Difference between each of those terms is -2. We're taking 2 off each time. First term, second term, third term, fourth term, fifth term. Next term is going to be 30. And the term after that is going to be 28. Okay, next couple of terms. What about this one? We're going down by 5 each time. Down by 5 each time. First term, second term, third term, fourth term, fifth term. Next terms are going to be 70 and then 65. We're going down by 5 each time. These are all examples of arithmetic sequences, the same difference between each of the numbers. Now, what about this one? We've got -10 first term, -12 the second term, -14 the third term, -16 the next term. So what are we doing? We're going down. Don't forget, we're getting more negative, so we're going down by 2 each time. The difference is -2. The difference is -2. The difference is -2. So the next 2 terms are going to be -18 and then -20 for our next 2 terms. What about this one? -5 to -2 to 1 to 4 to 7. Actually, we're going up 3 each time. We're increasing by 3 each time. Okay, so our next 2 terms are going to be 10 and 13. Okay, we're increasing by 2 each time. It's the same difference between the numbers, it's 3, and it's increasing each time. I think there's one last example here. 11 to 7, 7 to 3, 3 to -1. What's actually happening? We're going down 4. We're decreasing. We're going down 4 each time. So we're taking 4 off the number each time. So if we take another 4 off here, we go to -5. Another 4 off, we go to -9. the next two numbers in our sequence. I think that's the final example, because what we want to do now is we want to look at how we find our nth term. So I'm going to go back to one of the more simple examples. Okay. Now, let's have a little look at this. So we've got the first term, the second term, the third term, the fourth term, the fifth term. What was the difference each time? We were going up 2 each time. We're going up 2 each time. Increasing by 2. Just add 2, add 2, add 2, add 2. That's the first number you need to hold on to. So hold on to that number. Now what I'm going to do is ask you to go back. First term, second term, third term, fourth term, fifth term. I'm going to ask you to go back. What would be the previous term? What would be the previous term? We're going up by 2 each time. What would be the previous term? The previous term would actually be 3. That's the second number we need to get hold of. And the thing that I'm going to do here is that is a positive 3, so I'm going to make sure that we know that and understand that, and I'm going to put that plus there. Okay? So the difference going up is 2 each time. That's the first number I grab hold of. And then first term, second term, third term, fourth term, fifth term. I'll go back and I look at, and some people call this the 0 term. Some people would call this the 0 term here. We're making up a new term. We're getting to the previous term. And that's important. That's the second number we need to grab hold of. And then we're looking at the nth term here so that we can find any number in the sequence. We're going to put an n in there. Convention says we put an n in there. So now I've got my expression which will give me the nth term. So if the examiner, if the questioner was asking for the 50th term, I'd be able to find that 50th term without writing out the sequence. And just to prove how that works, first term, third term, first term, second term, third term, fourth term, fifth term, I'm going to have a look at let's have a look at the fifth term. So I've made up this nth term, this expression for the nth term, 2n plus 3. I'm going to try and find my fifth term to show you how this works. So instead of an n, I'll put in a value of 5 there. So 2 times 5 gives me 10, and then I add 3, and I get 13, which is my fifth term. Now let's just have a look at that again, see if we can make that work again. Don't worry about the writing on the bottom. Let's have a look at the fourth term. So if instead of n, I put in a 4, 2 times 4 is 8, plus 3 equals 11, my fourth term. What it does say down at the bottom, 50th term. 50th term, what's the 50th term going to be? 2 times 50 equals 100, plus 3, so my 50th term would be 2 lots of 50, plus 3, so it would be 103. That would be my 50th term, without having to write out the rest of the sequence to get up there. That's what my nth term allows me to do. And that's a lot to take in if you haven't seen that before, so I'm going to do another example. Right, with this example, I've already got written up there that the difference between each of those numbers is 3. So that's what I said to you, you've got to grab hold of that number. Grab hold of that number. What is the difference between each term? It's 3. It's going up 3. It's a positive 3. Then what happens when I go to find my 0 term? First term, second term, third term, fourth term, fifth term. Go back and get my 0 term. So I've gone back 3 from the 8. So my previous term is going to be 5. That's the second number that I need to grab hold of. And it's a positive 5, it's a plus 5. Now I put in my n. Now I've got my nth term. So let's just check and see if that works. First term, second term, third term, fourth term, fifth term. My fifth term is 20. Now let's see if that works. So fifth term. Instead of my n, I put in a 5. 3 times 5 is 15. Plus 5 equals 20. My fifth term, which is what I've got in my sequence. Let's have a look at my fourth term. First term, second term, third term, fourth term. If I wanted to find my fourth term, let's just check and see if my nth term works. 3 times 4 is 12. Plus 5 gives me 17, which funnily enough is my fourth term. Two numbers you need to grab hold of. You need to grab hold of that difference. You need to get your previous term, and then you need to bang in your n, get your n in there, and that gives you your nth term each time. Another example. Okay, what is the difference each time? The difference each time, we are going up by 3. So it's a positive 3. That's what we're going up each time. I went back and found the previous term. Go back 3, then minus 1. That's the second number I need to grab a hold of. Now I can bang in my n. That is my nth term. Now let's just check that. First term, second term, third term, fourth term, fifth term, 14. Let's see if it works. Fifth term. So my n has got a value of 5. 3 times 5 is 15. Take away 1 gives me 14. So it works. Let's have a look what my fourth term would be. 3 times 4 is 12. Take away 1 gives me 11. Works again, doesn't it? That's my fourth term. Okay? Going up by 3 each time, so positive 3 each there. Go and find my 0 term, my previous term. That's a minus 1. It's important that it's minus 1, so that's what you write down there. That's what we write down in our nth term. Then we bang in our n. We've got our nth term, our general term for n, which gives us the value of our term each time. And then we've checked it with 2 examples there. Okay, let's have another look at an example. We're doing lots of examples here, so you've got lots of vision across different types of question. What's happening each time? We're going down 2. We're going down 2 each time. So that's my first number that I need to grab hold of. We're going down 2, so it's minus 2. Then I want to have a look at what my previous term is. First term, second term, third term, fourth term, fifth term. In the sequence that I'm given, what is my previous term going to be? It's going to be 42. Okay? That's the second number I need to grab hold of. A little bit different to what you've been used to seeing. And what is it? Is it a positive 42 or a negative 42? It's a positive 42. So I've got my 2 numbers. I've got the difference between the numbers in the sequence, which is minus 2, because it's going down 2 each time. I've got my previous term, which is 42, and it's a positive 42. Now I bang in my n. Now I've got my nth term. Let's just check that. First term, second term, third term, fourth term, fifth term in the sequence I've been given. So if I want to do the fifth term, minus 2 times 5 because my n is 5. Minus 2 times 5 gives me minus 10. F42 gives me 32, which indeed is my fifth term, so it checks out. Okay? It checks out, it works. Another example, I make no excuse, there's loads of examples here to give you loads of opportunity to practice and see how these work. Okay, I'm leaving that up there, we're going down 5 each time, so that's the first number I need to grab hold of. The fact that we're going down 5 each time, my first number I need to grab hold of is that minus 5. I need to get my previous term. I've got my first term, second term, third term, fourth term, fifth term in the sequence I've been given. What would my previous term be? My previous term would be 100. That's the second number I need to grab hold of. And it's a positive 100. Now I need to bang in my n. That is my nth term, my general nth term. Let's have a look for the fourth term. So n is going to be 4. Okay, the nth term, the fourth term, minus 5 times 4 gives me minus 20, plus 100 gives me 80, which indeed is my fourth term. First term, second term, third term, fourth term is 80. Okay, so any term in that sequence that I'm asked to find, I can find by using that general term for the nth term. I can find any term in the sequence. Have we got another example we can look at? Yeah, let's have a look at this. I'll just quickly go through these examples just to make sure that you're going to be happy and confident with these types of questions. Right, what's happening? I'm going down 2 each time. Remember this when we looked at it first time. Gone from minus 10 down to minus 12, down to minus 14, down to minus 16. So that first number I've got to grab hold of is minus 2. What would the previous term be? It would be minus 8. So that's the second number I've got to grab hold of. Then I've got to bang in my n. So let's go back to my original sequence. First term, second term, third term, fourth term. Let's have a look at the fourth term. Minus 2 times 4 would give me minus 8. Then we've got minus 8. Minus 8 and minus 8 put together is minus 16, which indeed is my fourth term. And the final example I'm going to go through. Okay, we're going up 3 each time. So what's my first number I write down? My first number, because we're increasing by 3 each time, my first number I write down is a 3. What's the second number I write down? Find my previous term. My previous term is going to be minus 8. So we're going down 3 in this direction. We're going up 3 in the sequence. We've got to go back 3 to get my previous term there. So that's minus 8. Bang in my n. That is my nth term. Let's just check it. See what happens when we go to find the fifth term. Fifth term. So n is 5. 3 times 5 is 15. Take away 8 is indeed 7, which is my fifth term in the original sequence. If I needed to find my 50th term, what would I do? I'd just say 3 times 50, which is 150, take away 8. So 142 would be my 50th term in the sequence. My 100th term in the sequence would be 3 times 100. 3 times 100 is 300. Take away 8, 292 would be my 100th term. Okay, and that's how it works. The only other question that you might be asked, let's go back to a more simple example here. They might ask you something like, could 100 be in the sequence? Could the number 100 be in this sequence? So what would you do? if 100 is in the sequence, okay, if 100 is in the sequence, at some time 3n plus 5 must equal 100. If 100 is going to be in the sequence, let's just do that. 3n plus 5. Let's just give ourselves a little bit of room here. So 3n plus 5, if 100 is going to be in the sequence, that equation must work to give a whole number value of n, because first term, second term, third term, fourth term, fifth term, the term has always got to be a whole number. You can't have 1.5 terms, 2.5 terms, or anything like that. That's got to be a whole number if this is going to work. So if we went to solve that equation, that would mean 3n equals 95. Take away 5 from each side, which you know how to do because you know how to solve equations. So 3n equals 95, which means that n equals 95 over 3. And straight away, without actually working that out, does 95 divided by 3 make a whole number? No, it doesn't. So that means that 100 cannot be in that sequence, because that doesn't work to give a whole number value of n. Okay? N has always got to be a whole number. First term, second term, third term, it must be a whole number. If you don't get that whole number, it can't work. Okay, right, that's an introduction to sequences. We know a little bit about special sequences. It might just be odd numbers. It's a sequence of numbers that follows a rule, so it might just be odd numbers. It might be increasing by the same number, like an arithmetic sequence that we've looked at in more detail. It might be cube numbers, it might be squared numbers. Anything where there's a rule that governs what happens between the numbers is a sequence. Arithmetic sequences, it's got to be the same difference between the numbers in the sequence. Okay? And then to find an nth term, we're looking at the difference between the numbers, the previous term, and then bang in an n to give us an nth term. So those two things we need to collect. We need to collect the difference between the numbers. That's the first number you need to collect. You need to go and get your previous term, your 0 term. Once you've got those two numbers, bang in the n, make sure you've got those numbers the right way around, you've got your nth term, and you can proceed with whatever else the question asks you to do. Hopefully that's been useful to you. Thank you for your concentration, thank you for your commitment, and that concludes that particular lesson.